So we've got a question here where we've got two particles connected by a light inextensible string by a pulley system. And the mass of particle B is half the mass of particle A. And we've got tension in the ropes, which is labelled on the diagram. And the system is travelling in this direction. So what we want to know is what's the acceleration of particle B as it falls to the ground, or in this case rolls to the ground. Now there's an angle here of 30 degrees. So what we need to do is work out what the forces are at each end of the extensible string, and we need to use Newton's law of motion, force equals mass times acceleration. So F equals ma. That's going to get us to where we need to be to calculate our acceleration as the system here is moving. It's not actually in equilibrium. So let's start with the forces at B. So at B. So what's going on there? So first of all, let's see what the forces are. So we've got our ball rolling down the hill. So we've got tension going in the opposite direction. So we've got minus the tension. And we've got mass times acceleration. So we've got m times the acceleration. So it's m is the mass. So we keep that as m. So that's that side of the equation. Now we need to what's happening in this direction as the weight of this particle is acting against or acting with the gravity. So to do that, if I just draw a little triangle down here to represent this little bit here. So I've got that there, that's my particle. Now the mass will be falling perpendicular downwards to the ground. Now we want to find what the force is in this direction. So if we draw a line parallel to the base of the ground. So if I draw a line there and then draw a line perpendicular down to meet it, I will form a right angled triangle. Now, as this is a forces diagram here, which I'm kind of drawing here, we can use the triangle inequality where we connect the forces together in a triangle, and thus the length of the triangles will represent the magnitude of each force. So I've got m acting on that direction with the force of gravity. We've got an angle here of 30 degrees. So if this angle here is 30 degrees, if I draw that in there, if that angle there is 30 degrees, that'll be a right angle, so that'll be 60. I'll have another right angle here, so therefore this angle here is also 30. So it tends to be that this angle here is the same as this angle here. Now to find this is what we want. If I just call that R, we'll know that R is opposite to the 30, so hence we need sine. So sine of 30, let's just change that, sine, oh my god, I keep writing an N, sine of 30 equals R over mg. And then if we know what sine 30 is, which is a half, we know that this force here is a half of mg. So with that, we need to add 1/2 of mg. So if I just write that there, R equals 1/2 of mg. So just by bringing this across. So if I add 1/2 of mg, that will take care of that. Then look at A, what's happening with A. So at A, this time tension's going in the correct direction. And the force of gravity acting on this will be just in a line perpendicular to the plane there, and also acting on it will be the force of the coefficient of friction. So that'd be 2m times the coefficient of friction and gravity. So that'd be minus 2 mu and then mg. So 2m is the weight, g is the gravity, and mu is the coefficient of friction. And then setting that equal to mass times acceleration. Here the mass is 2m, so I set that equal to 2ma. Okay, now classic situation when we're dealing with forces diagrams, we've got two equations with two unknowns. So now what we can do is we can just subtract each from one from each other and then get t to disappear. So as I've got minus t plus t, if we add them, that t will disappear. Then you've got half of mg minus 2 mu mg. So I'm going to write that out as it is in the equations. And then add those together, simply 3 ma. Okay, so now we need to find the acceleration, so we need to get this a on its own somehow. So we've got half mg minus 2 mu mg and then 3 ma. So m is present in all three terms, so we can just get rid of that. So now I've got half of g minus 2 mu g equals 3a. So that's a bit easy to look at. So now I can take out a g. So let's do that. We've got our coefficient of friction, acceleration due to gravity there. We can put that in at the end. Then I've got a half minus 2 mu. And then that equals 3a. Okay, now what I need to do, just divide both sides by 3, and then I'll get a on its own. So then I've got a equals g over 3, 1/2 minus 2 mu. Then if I want to just get that fraction out of there, I can just divide this by 2 and times all of this by 2, in which case I'll get a equals g over 6, 1 minus 4 mu. So that be our acceleration. So if I put that in there, and then we can solve for what that value is. So I've got 1/6, and then I've got 1 minus 4 mu times all that by g. Let's plug in my g and my mu from what we got here. So I've got 1/6, 1 minus 4 times 0.11, and then g is 9.81. So plugging all that into my calculator, let's have a go at that. Approximately 0.9156. And that's meters per second squared. So the acceleration of this system is 0.9156 meters per second squared. Okay.